In this recording, I'm going to go over the Unit 2 project, the assignments that we've had so far, which were the study design, the data collection, and this week, the results assignment. So let's start back with the study design. In this one, you got to choose the variety and the color of M&Ms that you were going to study, and then write your statistical questions and post them in your blog. So I decided to choose the dark variety candies, and my color that I chose was red. Here are my two statistical questions. Where I got these statistical questions were from the study design assignment. I'm looking at the dark variety. The percentage it gives in the letter for that variety is 17%. In the study design assignment, I just took these two questions and copied and pasted them into my blog post, and I filled in the blanks. So I filled in dark for the variety, red for the color, and 17% for the percentage that came from the letter. Here's my blog post that I did for that. The next part of the project was the data collection part. For this part, I just collected a sample of the dark variety of M&Ms. I made sure that I got at least 400 of them. I counted how many I had altogether. I counted how many there were of the color I chose, which happened to be red. That would give me my frequency for that color, and then I divided the frequency by the sample size to get my sample proportion. Here's what I came up with. I counted my sample of dark M&Ms. I had a total of 449 of them. 54 of them were red. To get my sample proportion, I divided the 54 by the 449, and I rounded this number to 4 decimal places. So here's what I put in my blog post. My sample size is 449, the frequency for the red color is 54, and the sample proportion is 0.1203. Going back to my blog, here's my post for the sample data. The reason I had you post those things in your blog is that you're going to use some of those numbers in the assignment for this week, which is the results assignment. I'm going to go through this results assignment with you using my example numbers so that you can better understand what to do with this one. The first thing you need to do in this assignment is find an acceptable confidence level that will work with the sample data that you already have. You already collected your sample data, so you already have a specific sample size. When you decide what your confidence level is, you have to make that confidence level work with the sample size you have. So what we're going to do with this is use the minimum sample size formula. That's this formula right here. And you're going to work through this formula and see whether you get a minimum sample size that's smaller than the sample size you actually have. If you get a minimum sample size that's larger than the sample you have, then you'll have to go back and adjust your confidence level. The thing about this is that the minimum sample size increases as the confidence level increases. So if you have a really high confidence level, you might have a really large sample size, and it might be bigger than the sample size that you have. In that case, you'll have to decrease your confidence level until your minimum sample size is less than or at least equal to the sample size that you have. To get started with this, what you're going to do is start with the highest confidence level we would want to think about with this, which would be 99%. So go ahead and start with a 99% confidence level, and then you're going to work through this formula using that confidence level and see what you come up with. The first thing you need to do with that confidence level is to find the critical value that goes with it. And the way we would say this is Z of alpha over 2. You did some problems a little bit like this last week where you were finding these types of values and they gave you a subscript down here. The easiest way to find this value is to use StatCrunch. I'm going to start with 99%. I do have to change that to a decimal, so 99 divided by 100 is going to give me 0.99. In StatCrunch, I'm going to use the normal calculator. I want to use the between window, and I'm putting my 0.99 into this box. When I do compute, it gives me two values. I'm going to use the positive one on the right side. That's my Z value for that particular confidence level. And for these For these critical values, the most you should ever round them is to 2 decimal places. I'm going to go ahead and write mine down as 4 decimal places because that's what it gave me in StatCrunch. So I came down here and filled in the box with the number from StatCrunch. The next thing I need to find is the P star, and this is a number that I already have. This is the number from the letter, that's the percentage for the color I chose. I can go back to my blog post and find this. This should be the number that was in the second statistical question. For mine it was 17%. For this I need to change this to a decimal, so I'm going to divide it by 100, and that gives me 0.17. That's the number that goes in here. Just remember, this should be the number that comes from the letter. Another element that goes into the minimum sample size formula is the desired maximum margin of error. Usually if we're talking about proportions, we don't want to make this any bigger than 0.05 or 5%. For this particular project, I'm giving you a margin of error to use. We want our maximum margin of error to be 4%. That would be 0.04. So this is the value that you're going to use in this formula. Now you've got the 3 values that you need for the formula. So let's go back to what this formula was. And I'm going to take the 3 values that I have and plug them into here. So my value for the critical value was this. So what I'm going to have is n equals, this was the 2.5758. I'm taking that value and squaring it. Then my P star is the number that I got from the letter changed to a decimal. So that was 0.17 for me. The next thing here is the 1 minus P star, so that would be 1 minus 0.17. And then I'm dividing all that by my maximum desired margin of error squared, which for everybody this is going to be the same. This is going to be 0.04 squared. The things that are going to be different for you are this critical value, depending on where you are with your confidence level, and the P star and the 1 minus P star. This should be slightly different for everyone because it depends on what variety and what color of M&Ms you chose and the percentage in the Mars Company letter for that particular variety and color. I'm going to take all this and put it into my calculator. Since I'm using a graphing calculator, I'm putting it in just like I had it here with the parentheses and everything. That gives me an answer of 585.1. For minimum sample size problems, you always have to take this number and round it up to the next highest number, no matter what. So even though it's only a 0.1 here, I have to round this up to 586. That would be my minimum sample size. Now I'm back here. I'm going to put in the answer that I just got from my minimum sample size, which was 586. Now here's the real test. Is that minimum sample size greater than my actual sample size? If I go back to my blog post, I can see that my actual sample size was 449. So the answer is yes, this is greater than 449. Now, if it had been smaller than 449, then I could have put a no here, and in that case I could have skipped down to here. But since it turned out to be a yes, I'm going to have to go back and change my confidence level, because the confidence level I chose, 99%, won't work with the sample size I have. My minimum sample size is too big with that confidence level. So what I'm going to do now is go back and change my confidence level down to 98%. Only go down by 1% at a time. We want you to have the highest confidence level that you possibly can. So if 99% won't work, I'm going to go back and try this with 98%. What that means is that I'm going to have to go back and change my critical value so that it works with a 98% confidence level. This one was for 99%. For 98%, I'm going to change this to a decimal by dividing it by 100. I'm going to go back to StatCrunch and change this to 0.98, and there's my new critical value. So now I have a new critical value to use in the formula. The other values that I came up with are not going to change. So this is the only thing that's going to be different in my formula. So back here where I had 2.5758, now I'm going to have 2.3263. I'm still going to have my 0.17 and my 1 minus 0.17. I'm still going to have the 0.04 squared on the bottom. So I'm going back to my calculator. When I calculate that one, I get 477.2. I still have to round this up because we're talking about a minimum sample size, so I'm going to round that up to 478. So now I've got a new minimum sample size, which is 478. The question is whether it's greater than my actual sample size, which is 449, and fortunately, it still is greater than that. So this is still a yes, and that means I need to go through this again. So now I was at 98%. I'm going to go down by 1 percentage point down to 97% and recalculate. Again, the only thing that's going to change is my critical value. So now I'm doing this for 97%. That means for my critical value, I get 2.1701. There's my new critical value. So I'm going to go back and recalculate my formula one more time. This is the only thing that's changing, so I still have the 0.17 and the 1 minus 1.17 and the 0.04 squared on the bottom. This time I got 415.3. I would have to round that up to the next highest whole number, which would be 416. Now I'm down to 416 here. 416 is less than 449. So now finally, when it asks if my minimum sample size is greater than my actual sample size, this time I can say no. And that means now finally I can skip down to the last part of this part. So for this, I want to put in my final confidence level that I used, and that was 97%. So it may end up for you where you only have to go through this process once. You may have to go through it 3 times like I did, or you may have to go through it more. It just depends on what your numbers were in the first place. But you have to keep going through this until you get to where the minimum sample size from the formula is less than or equal to the sample size you actually have. Once you get there, then put in the last confidence level you used to get that, and that's the confidence level you're going to use for the rest of this assignment. Now we can go on to the next part of this, which is where we're actually going to construct a confidence interval. We're going to do this by hand, and then we're actually going to do it also with StatCrunch so that we have a way to check our answers. Here again, there are some boxes to fill in. Be very careful about where you get these numbers from so that you're getting them from the correct place. You should already have this critical value. It should be the last one you found when you were calculating your minimum sample size. For me, the last one I had was with a 97% confidence level. My critical value was 2.1701. That's the number that's going to go in here. This next value is the sample proportion. This is the proportion that you got from your actual sample of M&Ms. It's what you put in your sample data blog post last week. So for me, when I took my frequency for red, which was 54, and divided by 449, my sample proportion came out to be 0.1203. That's the number that's going to go into this box. So this is not the number from the letter, this is the number from your actual sample data. Same thing for the N here. This gets kind of confusing because we were just talking about minimum sample size, but this needs to be your actual sample size from your sample of M&Ms. This is the total number of M&Ms that you counted in the assignment for last week and what you put in for your sample size in your blog post. For me, this was 449. The next thing you're going to do with this is calculate an actual margin of error. This is completely different than the E used in the last part of this. This is something you're going to calculate using this formula up here. So now that you've filled in these boxes, you have everything you need to put into this formula. So for me, my critical value was 2.1701. My p-hat, my sample proportion was 0.1203. And my N, my actual sample size, was 449. Now I'm going to put this into my calculator. And since I use a graphing calculator for this, I like to put this all into one line. If you're trying to do it piece by piece, just make sure that you actually do the multiplication and the division here before you take the square root. That 449, or your value for N, is under the square root. Also, if you're doing this piece by piece, try not to round your numbers. If you do have to round, take them out to something like 6 decimal places so that you don't end up with a large rounding error. And this is going to be my actual margin of error. In the assignment, it asks you to round this to 3 decimal places. So for me, that's going to be 0.033. Keep in mind, this should be something fairly small because we're talking about proportions. Proportions are between 0 and 1. So the fact that this is 0.033, if I change this to a percentage, that would be something like 3.3%. That's not very surprising considering what we're talking about. So this is a reasonable answer for my margin of error. Now I'm going to use my sample proportion, which was up here, and my margin of error that I just calculated, to find my lower limit and my upper limit for my confidence interval. My margin of error that I just calculated was 0.033. So for my lower limit for my confidence interval, I'm going to take my sample proportion minus my margin of error. That gives me 0.0873. And this is asking me to round to 3 decimal places, so I'm going to round that to 0.087. For my upper limit, I'm going to take my sample proportion plus my margin of error. That gives me 0.1533. If I round that to 3 decimal places, that gives me 0.153. So here's my confidence interval that I calculated by hand. Now I'm going to use StatCrunch and check my calculations. In StatCrunch, I'm trying to find a confidence interval for a proportion. I'm going to use proportion stats. This is going to be 1 sample, and it's with summary. So this goes back to the frequency for your color and your sample size. The number of successes is going to be the same as the frequency for the color that you chose. For me, I chose red, and in my sample of M&Ms, I had 54 red M&Ms. So my number of successes here is going to be 54. My total number, my sample size was 449. That's going to be my number of observations here. I want a confidence interval, and here I want to put in whichever confidence level I chose in the end. For me, it was 0.97, or 97%. Now here are my results from StatCrunch. There are a couple of things that you can check to make sure that you put the right numbers in the right places. The sample proportion it gives you here should be the same as the sample proportion that you came up with. This is just taking the frequency of your color divided by the sample size. And here we've got the lower limit and the upper limit. These should be very close to what you calculated by hand. When I did the calculations by hand, I came out with 0.087 and 0.153. And for these two, if I round this one to 3 decimal places, I get 0.087. And if I round this one to 3 decimal places, I actually get 0.154, but it's very close to the 0.153. That's close enough that I can assume that that's correct. So now what I would do for this assignment is I would copy this and paste it into the Word doc. So I would paste it in here, and you can always do a screenshot if you can't get the copy and paste to work. Then once you've gotten through with all of this, the next thing is to write a confidence interval interpretation statement. This just says in a sentence what your confidence interval is, and it explains more about what the confidence interval is trying to estimate. So all this statement is doing is specifying the confidence level, the variety, and the color of M&Ms, and it's saying what the lower and upper limit of the confidence interval is that you found. Once you get done with this, be sure and save this file as a PDF. That way I'll be able to pull it up and read it. Go back to your Unit 2 project blog and attach your PDF file in a blog entry and then post the entry.